Good morning, respected Sheba sister and my dear friends. Myself Adulya K. Today I am going to deal with the topic laws of production. Laws of production describes technically possible ways of increasing level of production. Here output may be increased in various ways. Output can be increased by changing all factors of production. Clearly, this is possible only in the long run. Thus, loss of returns to scale refers to the long run analysis of production. Moving to next topic. Short run loss of production. In short run, output may be increased by using more of the variable factors, while capital and possibility of other factors as well as are kept constant. At least one input will be fixed and other inputs are variables. The marginal product of the variable factors will decline eventually as more and more quantities of this factor are combined with the other constant factors. The expansion of output with one factor constant is described by the law of diminishing returns of the variable factors, which is often referred to as law of variable proportions. It is associated with short-run production function. Graphically, the production function usually presented as a curve on two-dimensional graphs. Diagram. Figure A, figure B. Y-axis we have output, x-axis we have labor, in figure B, x-axis we have capital. In figure A, S is equal to function of labor, Figure B, S is equal to function of capital. Figure A, K1 less than K2 less than K3. Figure B, L1 less than L2 less than L3. Changes of the relevant variables are thrown either by the movements along the curve that depicts the production function or by the shifts of the curve. The most commonly used diagrams for the production function of a single commodity are shown in figure A and B. In figure A, each curve shows the relationship between X and L for the given K, V and Y, where X is equal to output, L is equal to labor, K is equal to capital, V and Y returns to scale and efficiency measuring parameters. As labor increases, ceteris paribus, which means other factors remains constant. Output increases, we move along the curve depicting the production function. If capital increases, the production function S is equal to F of L shifts upwards. Suppose if the other factor changes, there is a shift in the production curve. In figure B, each curve shows the relationship between X and K for the given L, V and Y. As capital increases, ceteris paribus, output increases, we move along the curve. If L increases, the production function S is equal to F of K shift upwards. The slope of the curves in figure A and B are are the marginal product of the factors of production. How do you will get marginal product? Using the first differentiation, primary derivatives, differentiating the production function with respect to capital and labor, you will get marginal product of capital and marginal product of labor. That is mathematically. The marginal product of factor is defined as the change in output resulting from a very small change of this factor, keeping all other factors as constant. Mathematically, the marginal product of each factor is the partial derivative of the production function with respect to this factor. Why partial derivative? Because there are two factors and you keeping the other factors are constant in order to do the differentiation of the factor. Partial derivative of the factor with respect to labor are MPL is equal to dou X by dou L. Marginal product of labor is equal to dou output by dou labor. Partial derivative of the factor with respect to capital is MPK is equal to dou X by dou K. Marginal product of capital is equal to dou output by dou capital. Graphically, the marginal product of labor is shown by the slope of production function is S is equal to function F1 function of labor K bar, V bar and Y bar. And the marginal product of capital is shown by the slope of the production function is S is equal to F2 of capital, L bar, V bar, Y bar remains constant. The principle of marginal product of a factor may assume any value, positive, 0 or negative. However, the basic production theory concentrates only on the efficient part of production function, on the range of output over which the marginal product of factors are positive. Diagram. Figure 3.8, figure 3.9. In y-axis we have output, in x-axis we have labor. In figure 3.9, in y-axis we have output, x-axis we have capital. At this point, dou X by dou L. This point, dou X by dou L greater than 0. This point, dou X by dou L less than 0. S is equal to function of labor. At this point, dou x by dou L equal to 0. This point we will name it as A dash. This point we will name it as B dash. In this point, dou x by dou k. At this point, dou x by dou k greater than 0. At this point, dou x by dou k equal to 0. At this point, we will name it as B dash. This point, C dash. In this figure, figure 3.8, K is constant and L is variable. In figure 3.9, K is variable and L is constant. As you know, when Tp is maximum, MPL is equal to 0. When Tpk is maximum, MPk is equal to 0. Beyond that point, what happens? Dou x by dou L less than 0. Here also, dou x by dou k less than 0 at this point. So, the range where rational producers will take a decision or working ranges of output considered by the rational theory, area A, P in figure 3.8, area B in figure 3.8. No rational firm would employ the labor beyond OB dash, capital beyond OB dash, since increase in the factors beyond these levels would result in the reduction of the total output of the firm. Ranges of output over which the marginal products of the factors would be negative. Ranges beyond OB dash in figure 3.8, in figure 3.9 OD dash in figure 3.9 imply irrational behavior of the firm and are not considered by the theory of production. Furthermore, the basic theory of production usually concentrate on the range of output over which the marginal product of factors, although positive, decrease, that is over the range of diminishing but non-negative productivity of the factors of production. The ranges of output is considered by the traditional theory are A dash B dash in figure 3.8, C dash B dash in figure 3.9. These ranges of output have been shown in figure A and B. Shortened that comes the marginal product of factors of labor, amount of capital. Thank you.